Okay, at this point you should have Canon 1 complete. And with Canon 1 behind you, it is time for us to move on to Canon 2. This video here is going to serve as an overview for all the videos making up the Canon 2 section. We're going to talk about the goals of Canon 2 and take a quick look at all of the videos involved. Now, why Canon 2? Well, we must start out with a whiteboard. You know, Logan, we do that every time. We must have a whiteboard. So why do we have Canon 2? Well, let's start out by drawing Canon 1. That's Canon 1. And Canon 3. You like that for a big jump. We're going to skip right over 2 for a moment. Now, Canon 3, that's the one everybody's waiting to get to. That's going to be created with the XNA framework. So it will be our first XNA game. Now, what was Canon 1? Well, it was a WinForm application. So let's go ahead and jot that down. It was a WinForm app. So what does that mean? It means that it was an event-driven application, right, Logan?
Right. It was an application that instead of looking for information, it simply waited for Windows to tell it when things happened.
Exactly. Now, in most modern games, we don't use event-driven models, do we?
Right. It's too slow. Windows isn't necessarily going to give priority to your game alone. As a matter of fact, it's not. Other things are happening inside of your computer. So what we want to do is get away from that so that we have a more dedicated set of things or dedicated loop for our game.
Precisely.
Just like you wrote, a game loop.
That's right. So we kind of need to bridge the gap between an event-driven model and a game loop. Now, the idea of Canon 2 is to create another version of the Canon game that complies with our requirements. Remember the requirements we talked about way back for Canon. We need to comply with those, but we need to create something that gets us a little bit closer to a game loop model as opposed to an event-driven model. Now, Canon 2 will be a WinForm application, so I'll go ahead and jot that down. But we're going to change its structure in such a way that we're going to implement a simple engine that is going to look very similar to the XNA framework that we get, right?
Right. We need to introduce the idea of an engine.
That's right. Now, we need to get rid of as many events as we possibly can that we had in our first WinForm app, our Canon 1 game. So that's things like, remember we had mouse move? While I write this down, what did mouse move do, Logan?
Well, mouse move simply notified the app of the fact that the mouse had moved while over the form.
That's right.
And it also delivered the location that the mouse was now at after moving.
And we had mouse down,
which told the app when the mouse button was pressed down.
Precisely. And we also had, well, we took advantage of form load, and we also took advantage of what else? Well, we had the tick event for the timer as well.
Right.
So we had, we'll go ahead and just put form load. And the tick. And remember, that's the method that's called every time our timer fires.
That was actually the event that was on the timer itself. But again, those were the events that we were using, whether from the form or from a timer.
So this time around, what we're going to do is we're going to change things up a bit. We're going to take mouse move and our mouse down. We're going to get rid of those, and we're going to create a polling system. Basically, in our simulated loop, which I say simulated because we're going to still have to use our tick event, we can basically query to see where the mouse is at. We can query to see what state is the mouse button in, and then we can act upon that information accordingly, right?
Right, and another thing that we'll do is that will mean that all of our code will run at the same speed. If you look really closely at Canon 1, you'll notice that the mouse operates independently of the game objects, because the game objects are driven from the timer's tick, whereas the mouse is driven from the mouse move event. And there's no speed based on the mouse move event, it's just however fast Windows gives you the messages.
Exactly.
So what we want to do is move away from that and move on to a system where everything runs by the same system, under the same system, at the same speed. And to do that, we'll be looking for information ourselves at a given interval.
Exactly. Now, another thing that we're doing as we are migrating over to this simple engine framework, if you will, is we want to follow the framework that's given to us by a basic XNA game. Now, when we create our Canon 3 XNA game, we're going to have some methods that we're going to be using. And let me go ahead and jot these down for the very first time here, if I can find where my mouse is at. There we go. We've got initialize. We've got load graphics content. We've got update. And we've got draw. Logan, take just a second. What do these do?
Well, to begin with, these are methods given to you inside of XNA, and they are methods that can be used to do certain things. Initialize is called so that you're given the opportunity to set up your game. You can initialize variables, objects, and get data ready to be used for your game.
Okay.
Then you have load graphics content, where the game is telling you that now would be a good time to get any external content loaded into the game. Generate any textures you need, load any external textures, models, or any other graphical assets that you would need. Update is going to be called as the game is running. As a matter of fact, once per, if you want to call it your tick now, this is the new equivalent of tick. This is going to be called at a specific interval, a rather fast interval, generally 60 frames a second. And this is called to update any type of game, well, I guess we could call it game mechanics, use the terminology we were using back in Canon. This is where you're going to want to update anything that moves or interacts inside of your game.
Okay.
And then finally we'll have draw. And draw is just telling you that, okay, go ahead and render your scene now. Okay. It's the good place you want to go to clear out the screen and draw everything in its current state.
So by the way you made things sound there, it sounds like these are kind of like game loops, but two different kinds of loops, right?
It's not that they're two loops. It's that the timing is simply decoupled.
Okay.
And the reasoning for this is actually kind of interesting. By default, update tries to always run and maintain the exact same interval. It always tries to maintain 60 frames a second. Of course, that can be changed if you want to, but it defaults to 60.
Right.
And the idea is, if you have a certain amount of space or screen space that an object is going to move per update, then the speed of that update is controls how fast things move. As a matter of fact, if you want to go to Canon 1 and change the speed of the timer, you'll notice that as you increase the speed, the target and everything actually moves faster, moves across the screen faster. And what update does is it gets away from that. It holds a solid rate. So it's all 60 frames a second. So if you don't have any time compensation, your objects will still move the same speed. Draw is handled separately from update so that you can draw at a different frame rate than you actually update your game objects. For example, if you want to lock to VSync on a monitor, you can't always guarantee that that monitor is going to be 60 hertz. It might be a CRT and it might run at 80 or 120 hertz. And you wouldn't want your game to run faster just because it's on a different kind of monitor. But you might want to establish VSync for a clear display.
Right.
So what that does is you could have your draw run at monitor speed, but you keep your update running at standard 60 frames a second game speed.
So for visualization purposes, you can't picture this as kind of being like two different game loops?
I guess you kind of could. It's just, in some cases, I picture it as one big game loop where it updates either or. It can update or hit update all the time and only sometimes hit draw if draw was slower.
Right.
Or it could hit draw all the time and only hit update if update was slower.
Sure. I just kind of like picturing this internally as two different things, since we can completely control the speed of them independently.
Well, that is one thing I was mentioning, though, is that the fact that they are decoupled.
Exactly.
Their speeds are independent.
Exactly. And you have two separate places that you're going to put this code. You're going to put code in update, you're going to put code in draw. So I like to take a beginner and have them kind of think of this kind of like two different game loops, one with the purpose of updating the state of the game, the other with the purpose of rendering out the game.
You can look at it like that, since in the way this is set up, you don't actually see a loop yourself. You
Precisely.
see what should happen in the case of an update, what should happen when you're ready to draw.
Okay, I just wanted them to kind of understand why I was trying to use like two game loops as an analogy in a way. I mean, in the end, it's your game loop, but you see what I'm getting at. So we can simulate this in our WinForm app by putting in, say, a second timer, like if we had another tick. So let me leave it like that. Let's take polling out at the moment. And here's what I want us to do. I want us to utilize all of these methods right here inside Canon 2. Even though Canon 2 is a WinForm application, I wanted to have an initialize, I wanted to have a load graphics content, I wanted to have an update, and I wanted to have a draw. Now, of course, we're going to have to change update and draw, aren't we?
Right, well, update exists within a control, so we'll have to do something else.
So we're going to call it like update scene and draw scene.
Right, and then draw scene just to go along with that.
Just so that we don't have any naming conflicts that makes the compiler just slightly unhappy.
Right.
It's going to let us, but it's just not going to be very happy. We don't want to do anything that makes the compiler unhappy, even for a single moment, right?
Right, we want to keep our code as clean as we can.
That's right. So what we are going to do is we're going to end up with two timers in WinForm 2. One that's basically going to drive update and one that is going to drive draw. And it will decouple these two main driving procedures, if you will, such that they both can run at different speeds. So we will put that into place. But I hope at this point you can see what we're doing. We started out with a very simple event-driven game, and we're going to move over to another model that is not going to be quite so event-driven. It's going to be event-driven in the fact that we're still going to have a timer that is going to kick off a tick for us. So that's where we're going to get our loop from, if you will. But outside of that, with the tick firing, we're then going to do things like, well, update our scene. Let's poll. Let's do things like find out where the mouse is at and update our player accordingly. Did he push the button? Is the game going? If the game's going, let's fire a projectile. Let's update the position of the projectile if the projectile has been fired. Let's update our target, etc., etc. So we're going to handle doing all of these things within this confined loop.
Right. What it all comes down to is we will make an engine for running the game.
That's right.
The only thing we're going to do is we need a driving update interval to tell our engine when to execute another iteration.
Exactly.
We're going to get that from a timer just because we don't want to get into writing like a low-level message loop or anything.
Exactly. And then with this framework in place, then we can go ahead and move over to XNA. And at this point, you're going to find that a lot of things are going to look very similar because we're going to be using the same methods, of course, initialize, load graphics content, update, and draw. Now, in our new game here, in Canon 2, we are going to make it just a little bit more object-oriented. Now, of course, C# is an object-oriented language, and everything's objects in C#. But what we did in Canon 1 was basically use these picture boxes. Now we're still going to use our picture boxes, but we're now going to actually create a class called GameItem. And with GameItem, we'll be able to associate an object that we derive from GameItem with its appropriate picture box. Okay, so we make GameItem, and GameItem is going to basically work as a template for a projectile, a target, a player, and we can derive from that and then associate it with its respective picture box. And then it's going to have some functionality that's built in that's going to be common throughout our different game items within the game.
Right. Well, in Canon 1, we took advantage of the fact that the picture box itself actually did have a position, and if thrown onto form, actually did represent a position, and basically could easily be used as an object. And when we get over into XNA, we're not going to have that luxury of where we can say, all right, arbitrary screen rectangle goes here. We can't just store a bunch of those. We need to define that ourselves.
Okay.
So that means we're going to need to define our own class instead of just relying on picture box. We're actually going to start that practice back in the WinForm form in Canon 2. Even though we've got the picture box, it'll be nice for a few reasons. One, we'll get used to writing the class in that manner. And two, it would be nice to have an object that has velocity in it. Because while we had our target, we actually had to store target velocity external to it. And it'd be rather nice if we had a class that actually had velocity as part of it.
Exactly. And in our implementation, we'll be talking about that. So right now, if you feel just a little bit confused as to what Logan's saying, don't worry. It's going to make a lot more sense in just a minute. Now, the reason I mention that is because before we start getting into the coding phase, we're going to introduce a very simple objects video. It's going to be called something along the lines of creating objects, a quick overview. Now, this is not going to be your true introduction to object-oriented programming. We're going to take a very close look at object-oriented programming coming up in Volume 2 in the XNA Extreme course. But at this point, you guys have created new objects. You've created like a new random, etc. We've done a lot of stuff with the Hyperion project as well by creating new rooms and items for within the rooms. But we'd like to take just a minute and really break down what's happening there since we're going to be doing it in Canon 2. And with Canon 2, I want you to be a lot more aware of what's going on compared to back in the Hyperion project where it was more of a just follow along and trust us. Maybe some of this will start to make sense to you. We'll see. But in Canon 2, we're hoping that a whole lot of stuff starts to make sense. So before we get into the coding phase, we want to spend just a minute and have a very simple creating objects video. So the videos that are going to be coming up, of course, we've got this section overview. We're going to move from here into the implementation plan where we're going to discuss what our plan of attack is for coding Canon 2. After that, we're going to take a look at creating simple objects. From there, we're going to start phase 1 of Canon 2, which is going to be creating the game item class. We'll move into phase 2, which is going to be creating the simple engine, into Phase 3, which will be the mechanics. Phase 4 is going to be gameplay logic. Phase 5 is going to be the HUD item class, and Phase 6 is going to be coding the HUD into everything so that the whole game is complete. So that is the objectives of Canon 2. Anything you want to add to that, Logan?
No, I think that pretty much sums it up.
All right, well, with that out of the way, let's go ahead and move on to the next video where we're going to take a look at the implementation plan for Canon 2.